Hello, everyone. Today, we're going to learn about robot sensors. Since the 1960s, researchers have been exploring robotic vision systems. Initially, these systems could only recognize block-like objects on flat surfaces. By the 1970s, they had advanced to the point where they could identify certain machined parts as well as indoor items like tables and telephones. Although research progressed rapidly at that time, it wasn't applicable in practical settings due to the enormous amount of information the vision systems handled. The hardware required to process this data was bulky and slow. With the development of large and super large-scale integration circuit technology, computer memory shrank in size, its cost plummeted, and its speed increased significantly, leading to the practical application of vision systems. In the 1980s, thanks to the rapid development of microcomputers, practical vision systems began to spread across various fields, including a substantial number dedicated to robotic vision. Robotic vision differs from text or image recognition in that it generally deals with three-dimensional images. It needs to understand not only the size and shape of objects but also their relationships, essentially grasping the spatial awareness necessary for a robot to operate. To achieve this, many challenges have to be overcome because visual sensors can only capture two-dimensional images. Thus, the same object viewed from different angles will produce varying images. Different positions and intensities of light sources also affect the brightness and distribution in the captured images. Although real objects may not overlap, there may still be overlapping images from a certain perspective. To address these issues, numerous measures have been taken, and new methods are continuously being researched. Next, let's learn about the classification of robot sensors. The tasks that industrial robots are designed to perform vary, and so do the sensors and the specifications they are equipped with. Sensors are generally categorized into two types: internal information sensors and external information sensors. First, internal information sensors. They are primarily used to collect data on the robot's body, joints, and grippers' displacement, speed, acceleration, and other internal information. Second, external information sensors. They are used to gather information about the interactions between the robot and its external environment, as well as its working objects. Now, let's look at the applications of robot sensors. Robot sensors are detecting devices that enable robots to sense measured information and convert the sensed information into electrical signals or other forms of output according to certain rules. This is to meet the needs of information transmission, processing, and storage. Commonly used sensors in robotics include two-dimensional visual sensors, three-dimensional visual sensors, force-torque sensors, collision detection sensors, safety sensors, electromagnetic sensors, fiber optic sensors, bionic sensors, etc. Two-dimensional visual sensors are a common type of visual sensor used in robotics. They can recognize and locate objects through image processing technology. Three-dimensional visual sensors can obtain three-dimensional spatial information about objects, which is used for the spatial positioning and motion control of robots. Force-torque sensors can measure the force and torque applied by the end effector of a robotic arm, used for force control and torque characteristic analysis of the arm. Collision detection sensors can detect collisions between the robotic arm and its environment. They serve as a safety feature for the robotic arm. Safety sensors can detect hazardous factors present in the environment. Electromagnetic sensors can detect the strength and direction of electromagnetic fields, used for the motion control of robotic arms in electromagnetic environments. Fiber optic sensors can detect parameters such as light intensity and wavelength, used for the motion control of robotic arms in optical environments. Bionic sensors mimic the structure and function of biological neural systems. They are used to achieve intelligence in robotic arms. The applications of industrial robot sensors are very extensive, including production line requirements, autonomous driving, service robots, and AR technology, among others. Conventional industrial robot sensors include pressure sensors, angle encoders, displacement sensors, temperature sensors, etc. New types of sensors have also been applied in industrial robots, such as visual, force, tactile, proximity, distance, attitude, and position sensors. The application of these sensors has improved the operability of robots. For example, a vision sensing system can identify and locate building blocks. We can see a detailed introduction to sensory sensors in the tables. In this lesson, we learned about the classification and application of robot sensors. You can look up information after class to find out where robots appear in daily life. With this, our course has come to an end. I hope that you have gained an understanding of the principles and technology behind sensors. Thank you all.